Okay, good evening. I guess some people are late. There are only 14 of us. Okay, so before I start, anyone has any questions? Oh, really? My email is broken email, right? What did I give? Let's see. Okay, Paul is saying I'm giving you different. Yes, homework 1, homework 2. So QIAN.CHEN@brooklyn.cuny.edu. So that's the. Oh, yeah, right. Okay. So that means I need to. I'm missing the dot. I'm missing the dot. So how do I? How do I change it? Okay, let me see if I can. I can change this. Actually, I cannot change it. Right. Okay. So homework 3, I'm missing the dot between my first name and my last name. So it's QIAN.CHEN at Brooklyn. 1.5 Q2777. Can we go over question 2 to 4? Are those homework? 1.5. Okay. I cannot do homework for you, but let's see. I'm gonna give you a hint. Okay. Yeah, Fujun, yes. It's QIAN.CHEN at Brooklyn. I guess homework, I forgot the dot in between of my names. Nine days ago, Fujun, I didn't see any email from 9 days ago. Let me check. Okay, I received from Kelly, from Zach, from Paul, from Raw, Woodley, Bixun, Damon, Paul. What is this? Email security. This really one. Oh, okay, Fujin, I did see your homework here. I'm not sure if you mean this one. And this one, that's just today. So today I received those of you. Also, Fujin, I received yours today. Then yesterday I received from James, Ali, Raj V. And then before that, I received on Sunday, I received from Darren May. Last week, I received from Zach Fuji, you have to send me again. I didn't receive your on this email. I didn't receive anything before yesterday. Before today. Today I did see you send something, your homework, but not 9 days ago. Let me see. 25. 2, 2, 4. Okay, Zeynep, question 224 from homework 2. Can you find the section? Get the section for me. Yes, Shahaya, yes. Yes, send your homework to my email. Let me type my email again so not to confuse you. PIAN.CHEN@Brooklyn. Okay, so on and so forth. Yeah, today, right? Today the homework you sent to me, I see James, I see Darren Mays. Yeah, I've seen Zeynep's. Yeah, Darren May, I have seen your homework. Yeah. Yes. Really one, yes. Oh, for homework 1, Fuji, homework 1, you don't need to send to me because homework 1, remember, is in the system. So don't worry about, so you don't need to send to me homework 1. Okay, 1.4, 224. Why is homework 3 due Tuesday and not Thursday? Homework is due 1 week later. If the homework is I give to you on Tuesday, we'll do next Tuesday. If I give you today, we'll do next Thursday. Can I change the time is due? Well, because this is not going to be graded by the system, right? You may submit a little bit late, but don't be too late, okay? I don't know, you change the due dates. Because I attend Tuesday late for some reason, I did not hear about changing the due date. That is homework is due Friday then. Send homework today. Yes, no, it will not. All right, so today, as long as you send today, will not count as late. Right? All right, so don't worry about too much about the details, and so the biggest question is, try to understand the content, be able to do the homework, and ready for the exams. Right? We have midterm exam. I will let you know the dates, and I will final exam. Okay, so be able to do the homework. All right, any other questions? Otherwise, I'm gonna go to those 2 questions being asked. So 1.4, 224. Two, 224. Okay, 224, so 1.4, 224 is saying, suppose that a particle moves along a straight line with velocity defined by this quadratic function. Right. So if velocity is a quadratic function, we know the displacement function is anti-differentiation, right? Will be a cubic function, or polynomial of degree 3. Where t goes from 0 to 6. Find the displacement at time t and the total distance traveled up to t equals 6. So you may draw this. So basically, this we want to find the integral from 0 to 6 and put a vt, put the absolute value of vt, right? Absolute value of vt. So anti-differentiate this. So what do we need to do? So this, if we draw it, we see that's a quadratic, that's an upward parabola. Upward parabola. And we can factor this v of t, right? So t minus 6 times t plus 3. So we need to split. We need to think about. So if we draw the graph, let me draw the graph with myself. Actually, let's go to the whiteboard. I think. Let's go to the whiteboard. It's good review for last class anyway. So basically, so set up the integral, we evaluate from 0 to 6, right? But then before we do that, because maybe we have, down below x-axis and above x-axis, so we need to find that. So we want to draw the graph. And then we see v of t, we're typing here, so v of t can be factored as v minus 6, v plus 3, right? So that gives us 2 zeros or 2 x-intercepts. So let's see, this is 6. This might be -3. So -3 and 6. So we know in between, so from -3 to 6, that's 9. So 4.5. Let's see. So this is a 3. Right. So each increment is 1, 2, 3. So will be 1.5, right? So that's one way to figure out the vertex. Or well, let's find a y-intercept. Y-intercept v is 0, so we have -6, 3. So let me extend this. Let's see, this is a -18. -18. So that's my y-intercept, right? So the vertex will be 1.5. So that's my line of symmetry. So that's a graph. So vertex may be somewhere here. Because I have upward parabola, right? Because my leading coefficient is positive. So my graph would be something like this. So let's see from 0 to 6. From 0 to 6, okay. From 0 to 6, so that's 0, that's 6. Actually, everything is under x-axis. Under x-axis, so that's fine. So we don't have, something above x-axis in between of 0 to 6. We don't have anything above x-axis and down below x-axis offset each other. So we just go ahead, integrate this. So who asked this question? This to me is a very direct question, because I don't want to do this homework for you. Let me see. Zeneb, so what was your question? Zeneb, what's your question about this? Oh, okay, all right. The next question is 1.5. 1.5. 2777. All right, this one actually also very obvious, right? You said I'm just going to give you a hint. 277. You see, integral have cosine square, the angle is pi t, then sine pi t. Use substitution, right? Let u be cosine of pi t. That's my hint. The rest is just, you try to figure out du, then you substitute in. If we had to integrate twice. Damon, you asked 277, right? Do you have to integrate twice? You don't have to. You don't have to. You see, you let u be cosine of pi t. Then what happened? Then du equals to negative pi and the sine of pi t, right? Then in the integral, you already have sine of pi t dt. That's just du divides, just negative du divided by pi, right? So negative 1 over pi, you can put up from the integration sign. All right, Damon, is my hand okay for you? All right, so you see du, so let u be cosine pi t, you have that part, right? The extra pi in the beginning. Because pi is a number. Pi is a 3.14, blah, 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 right?
I was, can you hear me, Professor?
Yes.
And I was confused over where the pi came from, the derivative of cosine pi t. Did you have it negative pi sine pi t?
Sine pi t, yeah.
Okay, well, that's where I was confused, but I got it now.
You got now, right?
Yeah.
Pi is just a number, right? Pi is just a number.
So the derivative of cosine pi t is negative pi sine pi t?
Yes, right?
Okay, okay.
Think about cosine 5t. Well, let's say 3.140, right? So derivative of that would be negative 3.14 sine of 3.140, right?
Okay, all right.
Yeah, so pi is just a number.
Thank you, thank
Okay,
you.
you're welcome. So any other questions? Okay, so today we're going to talk about, well, we're going to chapter 2. So we're going to talk about area between curves and determine volumes by slicing. So chapter 2 have a couple of methods. We have, let me see. Actually not, that's chapter 3. Okay, all right, so let's go to this one. Yes, so far we're able to find out area of a irregular shape with one side being irregular. The other 3 sides are still straight, right? So when we have straight sides, we call regular, right? Regular polygons. But so before this chapter, we're able to find out the area for any irregular shape with one side being a curve, right? So this chapter, we will be able to find out an area of any weird irregular shape with 2 sides being irregular. Means the 2 sides are not strict. Let's see. Someone type me something. It just joined because my laptop. Oh, Zachariah, we just started because I was answering some homework questions. So don't worry about it. I haven't taken attendance yet. All right, so take a look at this shaded area, right? So this is an irregular shape with 2 sides are straight and the other 2 sides are not being a curve. So we put on the coordinates, right? We treat the straight sides, we're treating as the interval from A to B. And then we see we have 2 functions. So 2 irregular sides we're treating as functions. What's the area of this shaded, of this irregular shape? Just areas under f of x, area under the top function, subtract the area under the lower function g. So the integrand we want to integrate from A to B, f minus g. Oh. Then the rest is the same as before. Right? The idea still comes from, right, finite world, we're cutting the irregular shape into n pieces of rectangles. We estimate the area of the rectangles, we add them up. Then we take a limit, we let n pieces run to infinity pieces. That's how we use the limit idea. That's how we come from finite world to infinite world. The idea is still the same. Okay, the definition is still the same. Just the integrand, we have f minus g now. Okay, the top function minus the lower function. Okay, that's it. That's it, f minus g. Okay, from the interval, in the interval from A to B. So let's see this one, this example. So we have 2 functions. We have f equals x plus 4, we have g equals 3 minus x over 2. And we want to find the area in between of 1 to 4. So let's see. If we draw the picture, we see the picture f will be the top function. It's a straight line, right? With positive slope. And g is a lower function with a negative slope. So we want to find the area of this piece from 1 to 4. This is do, integration from A to B, from 1 to 4, f minus g, f minus g. F minus g, we get 3x divided by 2 plus 1. Then we anti-differentiate by power rule. So we get this, we get 3x squared divided by 4 plus x. Then evaluate from 1 to 4, right? So we have linear functions. When we anti-differentiate, we get a quadratic function, right? So that's 57 divided by 4. It's just pure mathematics. We don't care about the units, right? This is 57 divided by 4. Let's see this one. So R is a region bounded above by the graph, bounded above by the graph of F, and below. Okay, this is given which function is above, which function is below. But normally we wouldn't get, we wouldn't know which one is above, which one is below. And also this is bounded between, so we're not given a specific interval. So we need to find out the interval ourselves. So F, we see it's a downward parabola, right? Quadratic function, it's a downward parabola. And G is a linear function, right, with a negative slope. Let's see if we have we do have the picture, right? So F is a downward parabola, G is a linear function, and we need to find out those 2 points where these 2 functions intersect, because we're not given a specific interval. We need to find bounded, region bounded, right? The region bounded by those 2 functions. So we need to solve for these 2 intersections. So equal those 2 functions, right? F equals G. So then we solve for this, we simplify it. So 9 minus x squared over 4 equals 6 minus x. We multiply 4 on both sides because we want to get rid of the denominator 4. So we multiply 4 with every term. So we have 4 times 9, that's 36, minus x squared. 4 times 6, 24, minus 4x. Then we simplify this. So we can move negative x squared to the other side and move 36 to the other side, becomes negative. Well, we can think, subtract 36, add x squared on both sides. So we get x squared minus 4x, minus 36 plus 24, that's minus 12, right? Then this can be factored, as x minus 6, x plus 2. So x equals to 6, x equals to negative 2, right? So x equals to negative 2, negative 6, negative 2, and x equals to 6, right? So lower limit is negative 2, upper limit is 6. So we set up the integral, right? Lower limit negative 2, upper limit 6. We know f is the top function, g is the bottom function, so we do f minus g. So f minus g, we simplify, we get a quadratic function, right? We anti-differentiate with the power rule. Then we evaluate from negative 2 to 6. Right? Quadratic functions, when we anti-differentiate, we get a cubic function or polynomial of degree 3. Right? After calculation, we get 64 over 3. Anybody has any questions? Very direct. So when getting the bounds, we just set the 2 functions equal to each other and solve for x, right? You're exactly right. Yeah. A lot of times we're not given specific interval and we want to find a region bounded by 2 functions. Bounded by, which means when 2 functions meet, when 2 functions intersect. When they intersect, they share the same points. Right? You see this point, that means add those 2 points, the 2 functions equal to each other. Right? At this point, f equals to g. At this point, f equals to g. You're exactly right. Okay, solve for x, solve for the variable. Okay, areas of compound regions. Let's see this one. Find the area of a region between curves that cross. Let f and g be continuous functions over an interval from a to b. Let R denote the region between the graphs f and g and be bounded on the left and right by the lines a and b. X equals a, x equals b. Remember, x equals a is a straight line, is a vertical line. X equals b is a vertical line, respectively. Then the area of R is given by integration from a to b, absolute value of f minus g dx, right? Okay, let's see this one. Finding the area of a region bounded by functions that cross. So if R is a region between the graph of function f of x equals sine x and g of x equals cosine x over the interval 0 to pi, find the area of the region R. Let's see the picture. We know sine and cosine off by pi over 2 degree, right? Or we could see sine function is transformation of cosine about pi over 2 units, or vice versa. So basically, sine and cosine are the same function. You know, one is a transformation of the other by horizontal shifting. We see here the blue one. The blue one is, what's the blue one? The blue one is our cosine function, right? You see this blue one is cosine function. Cosine 0 equals 1. Right? Cosine pi over 2 equals 0. And cosine pi equals -1. And cosine 2 pi equals 0. That's a cosine. The orange one is sine function. Sine 0 equals 0. Sine pi over 2 equals 1. Sine pi equals 0. Sine 3 pi over 2 is -1. Sine 2 pi equals to 0. So we want to find out the area bounded by those two functions between 0 and pi. Between 0 and pi. Right? So this is shaded. This is shaded part. And what's the difference? So we see from 0 to this pi over 4, cosine function is above sine function. But from pi over 4 to pi, sine function is above cosine function. So we want to split that. So we want to split the interval from 0 to pi into two integrations. So we want to set up from 0 to pi over 4, then plus the integration from pi over 4 to pi. And from 0 to pi over 4 is cosine minus sine. From pi over 4 to pi, we have to do sine minus cosine. So that's this one. So from 0 to pi, we split into two integrals, 0 to pi over 4 and pi over 4 to pi. In the 0 to pi over 4 interval, we have cosine minus sine because cosine is top function, sine is bottom function. From pi over 4 to pi, sine is top function, cosine is bottom function, so I have sine minus cosine. Then the rest is just anti-differentiate, right? How do I anti-differentiate cosine x? That just come from sine x, right? That's just sine x. Then negative sine x. Negative sine x just from cosine x, anti-differentiate, right? It's cosine x. Similarly for the second one. So then we just evaluate. Right? In the end, we get 2 radical 2. So 2 radical 2 units. Okay, anyone has any questions? Okay. So I'm going to give you 3 minutes to do 2.3. Try 2.3. And hopefully all of you, let me see how many of you I have, 21. So hopefully 21 of you all give me your answers, right? Type in the chat. So 2.3, 3 minutes. So I'm going to do myself also. So I'm going to show you. So remember this interval. Let me just write here. So we want to find from the interval pi over 2 to 2 pi, because I want to show you the pictures. All right. And f is sine, g is cosine. Let's go back a little bit so you can see the picture. Yeah, see the picture. So from pi over 2, that's here, pi over 2, right, up to 2 pi. So this point here will be pi plus pi over 4, okay, or 5 pi over 4. This point, this here, this x value. Okay, this requires some trigonometry knowledge. Yeah, we have to try to remember what is sine 5 pi over 4. Right, and also cosine 5 pi over 4. Or the pi plus pi over 4. Right. Remember, all students take calculus. So angle pi plus pi over 4 in the third quadrant. In the third quadrant, only tangent and cotangent become positive. Sine and cosine be negative. So sine pi over 4 equals to negative sine pi over 4, right? And cosine pi plus pi over 4 equals to negative cosine pi over 4. And sine pi over 4 equals to cosine pi over 4, right? Because 45 degrees. It's a line y equals to x, which is square root 2 over 2. Okay, what do you have? So we want to split into two integrals, right? Pi over 2 up to, from pi over 2 up to pi plus pi over 4, right? So this point is pi plus pi over 4. In this integral, sine is on top, cosine on the bottom. Then the second integral from pi plus pi over 4 to 2 pi. Cosine is top function, and the sine is the lower function. Then we will do cosine minus sine. I got a 2. I'm not quite sure if my answer is right. I got 2. 2 square root 2. Okay, Damon get 2 square root 2. 2 plus square root 2 is a carrier. Let me check mine. So anti-differentiate sine. That's from negative cosine. Negative cosine. That's from negative sine. 2 plus 2. 2 plus 2 square root 2. Then, so cosine pi over 2 plus pi. Or pi over 4 plus pi. So that's negative, negative become positive, negative, negative become positive. So root 2 over 2 plus root 2 over 2. Then minus become plus. Cosine pi over 2 is 0, sine pi over 2 is 1, become 1. Then sine x, sine 2 pi is 0, cosine 2 pi is 1, minus sine, minus negative, become plus, minus negative become plus. So 2 plus 1, 2, 3, 4. 2 radical 2. Okay, so let's see. 2 plus square root 2. 2 plus 2 square root 2. Right, I agree with Zenep. 2 plus 2 square root 2. Yes, Zachariah, right, forgot multiply 2, yes. Alexander, can we go over this one? Sure, let's go over this one. Okay, Alexander, can you see the interval from pi over, so from pi over 2, pi over 2 to 2 pi, we split into pi over 2 to pi plus pi over 4, union, or let me put plus in here, plus pi over 4 up to 2 pi. Okay, first, let's see if this makes sense to you. Does this interval make sense? Okay, so this interval makes sense. In the first interval, we see sine. In the first interval, we do sine minus cosine, right? And in the second interval, we do cosine minus sine. So when we anti-differentiate, so I'm going to do this. So anti-differentiate. All right, let's go to whiteboard. So we split into 2. The bottom we have pi over 2, pi over 2, and the top one the upper limit is pi plus pi over 4. And the integral in this one, because sine is on top, so do cosine, sine minus cosine, right, across dx. Oops. Dx, right? Then plus our second interval, is from pi plus pi over 4. Lower limit, upper limit is 2 pi. And the integrand is the opposite, is cosine x minus sine x. The rest, just anti-differentiation, right? Right, when we anti-differentiate, sine x is negative cosine x. Minus cosine x comes from sine x. Anti-differentiation of cosine x is a sine x, right? Then we want to evaluate at pi over 2. So we want to evaluate at the lower limit, pi over 2, and the upper limit, pi plus pi over 4. Right, that's the first one. The second one, let's add. Well, cosine x, anti-differentiate, that's sine x. And minus sine x, anti-differentiate the negative cosine, minus become plus, so that becomes plus cosine x. Then we want to evaluate this from pi plus pi over 4 to 2 pi. Okay, now let's do a little bit simplification. So negative cosine x minus sine x, let's just factor out the negative sign. Let's just do negative cosine plus sine. Right. So I put the negative sign in front. So I have inside I have cosine plus sine, right? So let's evaluate negative cosine pi plus pi over 4. Okay, this requires some trigonometry skills. Remember, all students take calculus. What does this mean? We have 6 trig functions, right? If the angle in the first quadrant, that means every trig function has a positive value. If the angle falls on the second quadrant, only sine and cosecant has a positive value. Others have negative value. If on the third quadrant, only tangent and cotangent being positive, all other trig functions are negative. So we have here pi plus pi over 4, right? The angle falls somewhere here. Pi plus pi over 4. So in the third quadrant, sine and cosine has negative value. So that means cosine pi plus pi over 4 just negative cosine pi over 4. What's negative? What's cosine pi over 4? Cosine pi over 4 and sine pi over 4 have the same value, square root 2 over 2, right? So negative, so this is negative. Let's put it inside the parentheses. And same thing, you want to use calculator. Well, by now you should be able to figure out this, because all this is from pre-calculus, right? You should be able to figure out this. Why is it pi plus pi over 4 and not just 5 pi over 4? You can think of 5 pi over 4. Those two are exactly the same. But for me, it's easier to visualize pi plus pi over 4 falls on the third quadrant. Falls on the third quadrant, and cosine and sine values are negative. Yeah, that is exactly the same. Because pi is 4 over 4 pi. 4 over 4 pi plus 1 over 4 pi is 5 pi over 4. Exactly the same. So it's the same for sine x, right? Sine of pi plus pi over 4 is negative sine pi over 4. So it's just a negative square root of 2 over 2. Right. Then minus negative become plus. Plus cosine pi over 2 is 0. Sine pi over 2 is just 1. Okay. And the second one here, of sine pi plus pi over 4, we know that as negative square root negative square root of 2 over 2. And cosine, oh no, I should do sine 2 pi first. Sine 2 pi is 0. Right? 0 is nothing, I don't bother to write it. Cosine 2 pi is 1. 1 minus sine pi plus pi over 4 is negative square root of of 2 over 2. Then my plus cosine pi plus pi over 4 is negative cosine pi over 4. So minus square root 2 over 2, right? So negative become positive. So those three terms become positive. So this we have square root 2 over 2 plus square root 2 over 2. That just becomes square root 2. So we have square root 2 plus 1 from here. Here we have 1 minus negative, both be negative, so become plus. We have square root 2 over 2 plus square root 2 over 2. Again, it's square root of 2. So that's why we have 2 plus 2 square root 2. That's the answer. Okay, let's see. Who asked this question? Okay, Alexander, does this make sense? All right. Can you just go over how you split up the initial bounds? Okay, let's go to the book. Once we go to the book, I won't be able to write on it. That's something the Blackboard needs to update. The Blackboard needs to be more advanced, just like a Zoom. Like Zoom, if it's in Zoom, I will be able to write on this. Okay, just follow my cursor. You can see my cursor, right? Right. You see, the first one is pi over 4. So how do we know it's pi over 4? Because sine pi over 4 and cosine pi over 4 have the same value, square root 2 over 2. So this point here is square root 2 over 2. All right. And then this point here, that's pi plus pi over 4. So cosine pi plus pi over 4 and sine pi plus pi over 4 is the same. Negative square root 2 over 2. So this one. Right? So this one. So that's why I don't really need the increment to be there. I know this is pi over 4. I know this is negative pi over 4 or pi plus pi over 4. Because sine pi over 4 equals cosine pi over 4. All right, so hope that makes sense. So we based it off the graphs of sine and cosine, right? Yes. Okay, any other questions? Okay, let's keep going. Okay, finding the area of a complex region. So what do they mean by complex region is we have to split the region into two intervals because the type functions are different. You see this one, if we want to find the area of this shaded region, right? We see the left-hand side as a function, is f of x. We see the right-hand side is a linear function, a straight line. So what do we have to do? We have to split the integration into two integrations. So we'll do from 0 to 1, 1 to 2. Okay, so how do we know that? Again, we need to solve for the intersection of those two functions. We do x squared equals to 2 minus x. Then we will be able to find out x equals to 1. It looks like visually, it looks like at x equals to 1, those two functions interact each other. So we split it into 0 to 1. Right? From 0 to 1, the area and f of x. From 1 to 2 is the area and the line and the g. Right? So from 0 to 1, just x squared. We anti-differentiate, we'll get 1/3 of x cubed. Evaluate from 0 to 1, we get 1/3. All right. So from 0 to 1, we anti-differentiate f of x, which is x squared. We evaluate to get 1/3. From 1 to 2, we find the area under the straight line, which is 2 minus x. We anti-differentiate that. We evaluate from 1 to 2, we get a half. Then we add up these two regions. So we get 5 over 6. Again, how do we know, we split from 1? We just set those two functions equal to each other, right? Set those functions equal to each other. From here, we can see, I'm going to type in the chat, okay? So x squared equals to 2 minus x. So that's just x squared minus x plus x plus x minus 2 equals to 0, right? And then we see we can put this in a factor form, x plus 2 and x minus 1 equals to 0. So we get an x value equals to -2 and 1. And of course, -2 is not in the interval of 0 to 2, right? Because we want to find the area from 0 to 2. F intersects G at two places, at 1 and at -2. But -2 is irrelevant from our question. So we want to find out the area under those two functions in the intervals of 0 to 1. So that's why at x equals 1, those two functions intersect. So that's why we split the interval from 0 to 2 into two intervals, right? From 0 to 1 and from 1 to 2. The rest is just anti-differentiate. From 0 to 1, we anti-differentiate f. From 1 to 2, we anti-differentiate g. Anyone has any questions? All right, let's keep going. Well, let's see this one. This one, I'm going to give you a hint. I want everybody to try it. So if we try to solve from the picture, it looks like those two functions intersect at 1. So we want to split from 0 to 1, then 1 to 3. All right. From 0 to 1, we want to find the area under f. From 1 to 3, we want to find the area under g. Okay, go ahead. Then type your answer in the chat. Okay, Alejandra, Li Zhen, and Alexis. Bixin, Damani, Darren May, Fujun, Golam, Jack, James, Reliwan, Rajev, Shihaya, Woodley. I'm hoping all of you participate in this, all right? So either you show me your answer or you tell me you're not quite getting it. Okay, please, because I only see. Yeah, please just participate so I'll be able to give you full credits for participation. Thank you, thank you. Try it. It's okay to make mistake, all right? If you have questions or if you are confused, just let me know. All right, so try and type your answer in the chat. Okay, 5/3. 5/3. What I got? I got 2. I got 8/3. 5/3. Oh, okay. So it seems all of you. So that means I made a mistake. So 2/3 plus half. 9/2 minus 3 minus half. That's 6/2. 5/2 minus 5/2. That's 4/2. 4/2 times that is 2. Yeah. Okay. Let's see. Paul is the first one to say 5/2. Ali said got the same. Shahaya says 5/3. 5/3. Really, Jack? 5/3. Deneb 5/3. Darren 5/3. Okay, really one is 8/3, same as mine. I got 8/3. James got 1 and 2/3. That's 5/3. Alexander 5/3. 5/3 square. Raw got 8/3. Bishin 5.5. 9/2. Okay, Damon 2/3. So far, the second. All right, I got 8/3. All right, I think the answer is 8/3. 8/3. Okay. All right. So okay, this thing region is defined with respect to y. Let's see this one. So this one we see the regions is being put in this way, right? This shape. So on y-axis we have C to D, the intervals from C to D. And we have left side is a function v, the right hand side is another function u, right? So u. So we can of course think. So basically we're turning this 90 degree, right? We're turning this 90 degree, thinking, all right, I'm thinking the left hand side is a function in terms of y, and the right hand side is a function in terms of y, right? Because if we turn 90 degree, of course, it is a function by convention. And the idea is still the same, right? Before we cutting with into n pieces on x-axis, and here we're cutting from C to D n pieces on y-axis. The idea is still the same. Then, find the area of each rectangle. The idea is still the same, right? Take a limit, we cut n pieces at first, and then we let n run to infinity. We have this integration. So we use u subtract v. U is the right one. U is the function on the right hand side. So we use the right hand side because if you turn 90 degree, you see U is on top, right? V is on the bottom. So we do U, the right hand side, minus the left hand side. So get this. All right, so get this. So we can cut n pieces, infinite pieces on y-axis. Right, think about the left hand side is a function of y in terms of y, and the right hand side is a function in terms of y. We do the right side function, subtract the left hand side function. Let's see this one. Let's see, this one we have done with by cutting on x-axis. Now, if we cutting on y-axis, we don't have the picture. Okay. You could just imagine your head, right? Or cutting. You're thinking we use the right-hand side function, subtract the left-hand side function. We use g subtract f. G subtract f. Then what about the interval? the interval. However, the function has to be written. So far we have y equals x squared. And we need to write down the function in terms of y. We want to write down x in terms, x is a function in terms of y. Oh, Damon, you're still doing the previous one? Okay, I got 8/3, and yeah, I don't find my mistake. Well, you keep trying, okay? But now we're in different things. So make sure you're following me, okay? So we can cut this piece of shaded region with respect to y, so which we see from 0 to 1, right? Then the left-hand side, g, so the g function is a top function in terms of y-axis. F function is the bottom one. So we can set the integration from 0 to 1 of the right-hand side, subtract the left-hand side. However, the only difference is this. You see, g is in terms of x. F is in terms of x. But we have to write the other way. We have to find its inverse functions. Let me write in the chat. So y equals to x squared. Right? That means x equals to plus minus square root of y. Right? But we won't have minus square root of y from the interval from 0 to 2. So from interval from 0 to 2, so we have x equals to negative square root of y. Okay, tell me if this, if this doesn't make sense to you, let me know. Because right now we're cutting y-axis, all right? Basically, we want to set up integration with dy. Integration dy. So we're cutting on y from 0 to 1, right? Because 0 to 1, we see the intervals from 0 to 1 if you look at the y-axis. So we have to write the left-hand side and right-hand side as functions in terms of y. So f function now, right. So f of x equal to x squared. We want to write the function of x equals to square root of y. Oh, sorry, I read a negative square root of y. X equals to square root of y. Paul is saying if is the 0 to 2, you mentioned the x value domain or y value domain. All right. So now, so Paul, we want to, because we want to cut on y-axis, so thinking, so how do you think? Think you're turning the coordinates 90 degrees. Thinking this way, okay. If that confuses you, or thinking this way, writing f of x equals to x squared as x equals to square root of y. Okay, so writing x as a function of y. This is a little bit confusing in the beginning. Are we supposed to solve this one, or is it just an example? It's just an example. Okay, for this typical one, there's no need to do that, right? It's perfectly fine to cut on x-axis. But we want to do another way, cutting on y-axis. So soon you will see the convenience. Soon you will see the convenience why we sometimes want to cut a y-axis. So for now, just trying to follow me because we're cutting, because we want to set this way. Let me go to the whiteboard. Let me write this down. So f equals to 2 minus x. This, right? So g equals to 2 minus x. F equals to x squared. Let's go to whiteboard. Let's see. So basic, oops. So what we want to do is we want to be able to do this. Okay. Integration of, for this typical example from 0 to 1, we want to set up this way. We want to cut, let me see if I'm able to draw the picture. So I have x squared here. A function here. So this is 1. This is 3. This is our region, right? And we want to be able to do another way. Another way is this, to cut in this piece horizontally. We want to cut this way, right? So we want to set dy. We want to cut from 0 to 1, infinite many pieces. Right? So basically, you're thinking, you're turning these coordinates 90 degrees to think about that. All right? Turn your computer 90 degrees, counterclockwise. Then you will see this right-hand side, this was g before. So g of x equals to 2 minus x, right? Yeah. And this is f of x equals to x squared. Right? Now if we turn this 90 degree, because we want to cut along, we want to set up this integral. We want to cut along y-axis. So what do we have to do? We have to do the right function, right? The right-hand side, we should be able to write a function in terms of y. So that means we need to change that function in terms, so g. So x, so we start with g of x equals to 2 minus x, and that is x equals to 2 minus g of x, right? That means writing the function x in terms of y equals to 2 minus y. Let's see if this makes sense. So this the right-hand side function is 2 minus y. So I have my right-hand side. So u, remember u of v, that's my u of v. X of y is my u of v. So it's 2 minus y. That's my right-hand side function in terms of y, minus the left-hand side. What's the left-hand side? So f of x equals to x squared. That means x equals to plus minus square root of y, or f of x, right? In the interval of 0 to 3, or 0 to 1, x just equals the positive square root of y, right? So that's why I have the integrand is 2 minus y, the right-hand side function in terms of y, minus the left-hand side function in terms of y, which is just square root of y, minus square root of y. So that's my integrand. So the left-hand side, the right-hand side is a function in terms of y because I'm cutting along y-axis. I'm cutting along y-axis. So I have to write the two functions in terms of y. So the right-hand side is 2 minus y. The left-hand side is the square root of y. So I have 2 minus y minus square root of y. Then I integrate from there, right? So when I integrate, what do I get? I get 2y minus y squared divided by 2 and minus y raised by 3/2 multiplied by 2/3, right? 2/3 of that. Then I evaluate at 0 and 1. 0 and 1. Well, every term has y in it. So at 0, I get nothing. That's just 0. At 1, what do I get? I get 2 minus half, right? Y squared divided by 2, just half. Then minus 2, right? 2 minus half is 1.5 or 3/2. 3/2 minus 2/3. What do I get? I get 6. No, I get 9. 9/6 minus and multiply by 2 minus 4/6. So 9 minus 4, 5. 5/6. Right? 5/6. This has to be exactly the same as before. Did we get a 5/6 before? Let me go back to check. Yes. Yes, it was 5/6 before. Any questions? Okay. So we see, so we can cut along x-axis, right? Cutting along x-axis. Cutting along axis means, you know, we cut rectangles this way, cut along x-axis. Or then in that case, we will have dx, right? We would set up integral from 1 to 3 f minus g, right? Oh, not f minus g, just you know, set up an integral, right? Dx. Also, we can cut along x-axis and y-axis, going from the intervals on y-axis, then do dy. Shahaya, I think you are getting lost. We're not talking about the homework. We're talking about examples. We're not talking about the homework anymore. We're talking about this one. We're talking about this one was cutting along x-axis, right? So we get 5/6 as a solution. Now we're talking about, well, the same piece, but cutting along y-axis. And we just did the calculation, we still get 5/6. So that tells us we have a choice. Sometimes it may be convenient to cut along x-axis. Sometimes it may be convenient to set up an integral along y-axis. All right, let's keep going to see more examples. Right, this one is a/3, okay, Shahaya, this one. So actually, let's try this. Do I have time? No, I don't have time anymore. So I would encourage you to try on your own. To try this one, cutting along x-axis, cutting along y-axis. Okay, you should get the same answer. That means you want to rewrite the f function as a left-hand side function, right? You want to write as x equals to y squared, right? You see, you get x as a left-hand side function in terms of y, which is y squared. The right-hand side, you also want to write x equals some y. You solve for x. You basically get its inverse function. You get its inverse function in terms of y. Then you do the right-hand side, subtract the left-hand side, set up integrals from 0 to 1. Okay, let's pick up some questions from here. So for the following, find area in between. All right, so let me write down this. I will post on. So this is homework number 4, section 2.1. Let's do 1, 2, 3. You see 3 is tricky, right? You have to split the two integrals, split into two integrals. Let's do 4, 1, 2, 3, 4, 5, 6, okay, 7, 9, 10, 11. All right, so let me choose cover from here too. So 16, 18. Okay, that should be enough. Or then more. Okay, 22. 25. Okay, 25, you can see it's cutting along y-axis. All right, let me see if you have any questions or any comments. You're still on the whiteboard. Oh, I'm still on the whiteboard. All right, I'm sorry. Thank you. So homework 4 is due next week, right? Next Thursday, because today's Thursday. Homework 4 is due next Thursday. All right, so you have 1 week to do the homework. All right, I will post these questions. Yeah. Okay, let's start in talking about volumes. I forgot, how do we know to which quadrant we should shift the area? Woodley, for now, you don't have to worry about. Okay, time will comes along. You have to, it's better to integrate over y-axis. All right. So for now, don't worry about it. So now I want to start, we have 10 minutes. I want to start talking about volumes. So now we have no problem to find areas in between of two regions, right? In a region bounded by two functions. With that, so the idea comes from this. Okay, so we have an irregular shape. And how do we find its volume? Right? We can put an axis for this one. We can think we're finding the area of each section. Remember the idea of section? Then we just accumulate all the area of this section, right? Let's say this irregular shape. So we want to find area at x value. From A to B, we can find the area of this section. Then we just add up all the areas, right? So that would be the volume of this one. Right, so the integral now is an area. It's not a function of line, right? It's not of one it's not a one dimension value anymore. Because remember, we used to have one dimension value, right? The integral is just f of x. F of x is just a function, right? It's just one dimension value. So now the integral becomes two dimension value. So the integral measures area. Then we add up all those areas. So we get a volume, we get a three-dimension value. So let's see this one. Deriving the formula for the volume of a pyramid. So we know from geometry the volume of a pyramid is 1/3 of A times H, right? The area of the bottom, the base. So 1/3 of the area of the base times the height. The pyramid has a square base, so this becomes 1/3 of A squared, right? If the base is a square H. So pyramid looks like this, right? So what do? We just find the area of each slice, area of each section. Then we add up all those areas. So what is the area of this? In this case, we just have A squared, right? Area equals S squared, that equals to, well, where does S, so what does S? S is this, S squared. So how do we find S? So basically the pyramid, so let's see, this is the A, the base is A, right? We have similar triangles. So S, the ratio of S and A, and of the height, in this case, look at the top line, the size, the top size, right? Similar triangles have the same corresponding size ratio. So we use that relation, we say, okay, S, the ratio between S and A is the same as X over H, as X value over H, the height of the pyramid. Right? So typical S, right? So from here, we get S equals to AX divided by H. So we just substitute in there. So the area equals S squared equals AX divided by H squared. So we integrate from 0 to H, right? From 0 to H, from 0 to H. So the area is AX squared, AX divided by H squared, A squared divided by H squared. That's just some numbers, right? H and A are some numbers. And we just anti-differentiate this X squared, right? So in the end, we see we get 1/3 of A squared times H, right? So the pyramid has a square base. The formula is 1/3 of A squared H. So we just confirmed by this calculus idea. Any questions? All right. Okay, we don't have time to try. You may try this. You may try to find the volume. You may derive the formula for V, for the volume of a circular cone. A circular cone means the base is a circle, right? The area of the base is a circle, is pi r squared. So 1/3 of pi r squared H. You may try that. We just don't have time to do that. What is the benefit of slicing it? Well, we're just using this idea for future one, for irregular shape, all right? Yeah, this just proves then. This is to show you this works. This is reasonable. All right, let's see. If we have something, just imagine, right? We have an object like this. How would we find the volume of this? Right? If we have an object like this, like a vase, how do we find the volume of this? So the idea is, you know, cut this one in half, because we see the symmetry here. Then we put the piece on the coordinates. Then we think about the objects as if we rotate in this area, this region, we rotate this region over x-axis, right? So when we rotate, we get these 3D objects. And then we see the section, if we cut this one, each section just a perfect circle. A perfect circle. So how do we find the volume of this one? We set up an integral, right, with dx, right, from lower limit to upper limit. Then we just add up all the areas of circle at a specific x value. So the integration of the area of each section, right? So again, it's this idea, it's the formula here. It's this, right? The cutting dx, right? Cutting x into infinite pieces from a to b. The integrand is 2-dimension value. It's an area now. Right? It's area now. So how do we find the area of a circle? Pi r squared, right? Pi is a constant number. How do we find the r? Do we see r is just the function value? Because the top is still a function. The orange piece on top is a function. Do we see? So for a specific x, maybe let's see this point B, we see the radius just f of b, right? So the pi r. So in this case, just r is f of b. So pi f of b squared. Okay, so we don't have time to go into detail. So next time we're going to talk about this. All right. We're going to talk about how to find volume for irregular shape. All right. So I'm going to post your homework 4, on my Open Math and also on Blackboard. Anyone has any questions? Try to be very good at finding areas because the future topics all depends on this. All right. So we need to know how to find an area cutting down along x-axis or cutting along y-axis, because we're going to revolve or rotate the piece of area with x-axis or with y-axis or with another line, another vertical line or horizontal line to form a 3D objects, then to try to find the volume of the 3D objects. All right, so anyone has any questions? I saw homework 2 today and I was wondering if you saw it. Oh, you sent homework 2 today. Zakaria, yes. Yeah, I see some of you have sent your homework, homework. I was looking through the textbook on section 1.4 for the homework and I could not find the questions you wanted us to do. Could I get an extension for homework 2? Yes, Jack. Just when you send it in, just write down for everyone. When you send it in your homework, write down your homework number, okay? On the title, subject title, just write down your homework number. So by the date, I will know, even it's late, but still submit your homework, all right? Other homework question in the textbook, yes, Jack, except homework 1. Homework 1 is in the system. Homework 2, 3, and today 4 will be from the textbook. You could not find them? It's right here. Can you find the text? So the text I'm showing you, do you know where to look for them? Did you see question 207, 1.4? 1.4. Yes, you just keep going. You just screw down to the bottom. This is a 239 already, right? 224. How can you not find it? Right here, 207. Right? You just keep going down. So each section follows exercise. Each section has that. You just keep going, screw down. We're using my open math textbook. Yes. Oh, okay. Don't use Stewart. Do not use Stewart. So this is on. Let me go from the very beginning. Do you see this textbook? Let me stop sharing this. Let's go to. Let's go to my open math. Right, my open math. Go to your course. That's your course. You see homework 1, homework 2, homework 3. That's your calendar. You see right here, a calculus test. So that's the textbook. You click on it. That's this one. From here, you should be able to look for every section. 1.4 here. So today, 2.1. The homework is just following. You keep going down. It's here. Each section followed by exercises. All right, any other questions? Okay, have a good night. Oh, I take this. Have a good night. Stop.